Expected value is an important tool in yield management, and yield management is an important tool for the hospitality industry. You can see that in this little Arms Hotel scenario. Let's take a look. The Arms Hotel has 56 rooms. Okay, it's pretty small. A rented room represents $150 in profit, while turning away a customer who made a reservation, but the Arms Hotel did not have a room, costs $100. Okay. However many reservations the Arms Hotel accepts, there's a 50% chance that exactly that number of customers will show up to claim their reservation, and a 50% chance that one less than the total number of reservations will show up. Oh, right. So, wait, before we look at the question, that's what I mean by yield management. Notice that there is a limited resource, 56 rooms, pretty small hotel, and there is a cost of overbooking, essentially, and there's a cost of obviously beneficial use of the capacity. Now, what was asked? Says, what are the two future states of nature that Arms Hotel faces? Right, expected value relies on you recognizing the future as being a set of distinct states. And in the case of Arms Hotel, there were only two futures that were mentioned. What were the two possible futures that Arms Hotel faces every day? Basically, all reservations show up, right? Or one less than total reservations show up. The key with future states of nature is that this is everything that could possibly happen, okay? And only one of these futures will actually happen. Only one of them can happen. Okay, all right, well then that answers that question. Now, next question. What is the expected value of the policy of accepting exactly 56 reservations? So the hotel has 56 rooms, and we're to gauge the value of taking exactly 56 reservations. All right, to do that, first off, you want to list the future states of nature. Now, we said, well, we already did that. It is all reservations show up, or one less than the total number of reservations show up. Yes, but we can be a little more specific now, because the question said they're going to take 56 reservations. So what exactly are those two futures, right? All 56 show up, or 55 show up. Because these are the only two things that can then happen. Now, what's the probability of either of these? Well, that's that 50%. Well, okay, I'm just kind of getting organized here table-wise. And then, one other thing before I address this question. What's the outcome in each case? Because the assumption is in classic decision theory that for every future state of nature there's some value, good or bad, to winding up in that future. From what information we're given here, what's the value of, for instance, 56 customers showing up? Oh, well, we can determine that, because if 56 customers show up, didn't they say something about value here? Look at currency signs. Yes. A rented room is $150 in profit. So if 56 people show up, that's 56 rented rooms, 56 times 150. I get a payoff, so to speak, of $8,400. Okay, that's nice. Now that's only if all 56 show up. What if 55 show up? Well, 55 show up, it should be something similar. 55 rented rooms, $150 for each room, so it's slightly less, $8,250. Oh, all right. Now, I'm just staging information. We haven't but we're ready to answer the question. Because the question was, well, what's the expected value of taking 56 reservations? How do you calculate expected value? First off, just general formula. Expected value of anything is the sum of the probability of each future state of nature times the outcome under that future state of nature across all future states of nature. So you say, okay, in Arms Hotel, what's this mean? It means, all right, there's a 50% chance, right, 0.5, of 56 people showing up. This is the X over here, the value of that. Okay, 56 times 8,400 plus probability, 50% again, times, wait a minute, this particular 50% is the chance of 55 people showing up. That's only worth this. Fine. Put that number there, 8,250 equals, all right, I get 8,325 as the expected value of taking exactly 56 reservations. Because how do you calculate expected value? Right? The probability something's going to happen times the value of that thing happening. Plus the probability something else is going to happen times the value of that thing happening. Plus, and if there were more future states of nature, we would just keep going with this. Oh, okay, so there's actually the answer. The expected value of taking exactly 56 reservations is $8,325. What are the other questions? What is the expected value of a policy of exactly 57 reservations? Oh, okay, well, we can do this. This is the same exercise, sort of. We have to be careful. Now they're asking about 57. So, first off, list the future states of nature. Well, all 57 might show up. Or, in the case of Arms Hotel, the only other thing that can happen is one less than that, so that's 56 show up. Okay, these are the future states of nature. The probability, that didn't change. That's still the 50%, the 50%. But the outcome, the payoff, the value. Okay, I need to be careful here. I need to evaluate the overall value of 57 customers showing up, the 57 reservations showing up. So I'm thinking of the context of Arms Hotel. If 57 people show up with reservations, all 56 rooms do get rented. You earn $150 in profit on each room. I mean, we were told this. But if 57 people show up, they have reservations, somebody's going to be disappointed because there's only 56 rooms. Oh, so someone's going to be turned away who had a reservation, and there was a cost associated with that. We didn't use it last time because this situation didn't come up. But it says here, right, turning away a customer who made a reservation has a cost of $100. $100. You could say, if you wanted to, one customer, because it's 57 times 100. Except, wait a minute, it's a cost of. So this isn't a plus, it's a minus. You make this in profit and then you pay this penalty because of the one person you turned away. All right, now I get that overall bottom line is $8,300. Okay, so that's the value of 57 people showing up. The value of 56 people showing up, we saw that, right? I mean, I can write it out again, 56 times 150, but actually, deja vu, we've seen this before. That's 8,400. Okay, the question is asking, what is the expected value of taking 57 reservations? Okay, so we say 0.5 for 50%, 50% of this, 8,300, plus 50% of that, just another way to write it, 8400 equals, all right, I get on my calculator an expected value of 8,350. So, to answer the question, the expected value of taking 57 reservations is 8,350. Oh, now, speaking of this information, the Arms Hotel already has 56 reservations for tomorrow. Okay. A customer has just called who wants to book a room. Should the Arms Hotel tell this customer yes or no? Now, they only have 56 rooms. They already have reservations. Someone's on the phone and they'd like to make a reservation. You might think intuitively, well, of course you're not going to take it because you're already full. Except, wait a minute. Expected value. And I'm just summarizing what we already know. Expected value, the rational value, supposedly right now, of 56 reservations. That was the answer to part B. I mean, what was that number? It was 8,325 versus what did we just work on? 57 reservations. And what was that number? 8,350. Which of these two is more valuable? Which is the higher number? The higher number is associated with taking 57 reservations, even though you only have 56 rooms. This is overbooking. So what should the Arms Hotel tell the customer who's on the phone? Tell them yes. Because you would prefer to take 57 over 56 reservations based on the expected value of those two policies.